Hi students, in this video we're going to cover roots and the quadratic formula. Our objectives are to learn the discriminant and to determine the number of real solutions for a quadratic function. All right, so the following three things are in some way when a quadratic function equals 0. So you have roots, and that means that if you substitute the value into the function, you get 0. 2, you have x-intercepts, and that's going to be places where the graph or of the function either crosses or touches the x-axis. So you can see that we have two x-intercepts, one at -1, 0, the other one at +6, 0. Or you have zeros, which are solutions to the equation. And so all three of these use the equation x squared minus 5x minus 6. And the third one, we set that equation equal to 0. We factor and we set each factor equal to 0. That's how we get -1 and +6. Roots, again, or if you take the -1 or the 6 and you substitute them into the equation and you get 0, that means it's a root. But all three of those things are equivalent. We're going to cover them in this section. So the quadratic formula, remember that if you have the general form for a quadratic formula, it's ax squared plus bx plus c. And for that, the solutions to the quadratic function can be found using the quadratic formula. We all know this. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. And the value b squared minus 4ac is what we call the discriminant. And the discriminant is going to tell you the number of real number solutions that you have for that quadratic function. And we say real numbers, we just mean that you don't get that I part. There's no imaginary number or no imaginary part. So there are three cases of the discriminant. The first case is that b squared minus 4ac equals 0. And that's going to mean you have exactly one real solution, which means that the parabola is going to touch the x-axis and turn around. And the example function for this is x squared plus 6x plus 9. If we substituted that value into the discriminant, so we see that a is 1, b is 6, and c is 9. So the discriminant is going to be 6 squared minus 4 times 1 times 9, which is just 36 minus 36, which is how we get 0. And when that happens, your solution is the vertex of the parabola. And so in this case, that's x equals -b divided by 2a. We learned that in the previous section. So -6 divided by 2 times 1 is obviously -3. And we can see that is the only solution for this quadratic function. And again, that's when b squared minus 4ac is exactly 0. You get one real solution. The second case is if b squared minus 4ac is greater than 0. And then you're going to have two real number solutions, which one is the positive part of the quadratic formula. The other is the negative part of the quadratic formula. So in the case where we have x squared plus 8x plus 7, the graph is to the right. The two solutions are -7 and -1. If we substitute a, b, and c into the discriminant, we're going to get a is 1, b is 8, c is 7. And so we're going to have 8 squared minus 4 times 1 times 7, which is really just 64 minus 28, which is 36. And so the discriminant we already know is 36. So we're really doing over here -8 plus the square root of 36, or -8. This should be a minus, my apologies. Or you're doing -8 minus the square root of 36. And we know the square root of 36 equals 6. So our two solutions are -8 plus 6 divided by 2 and -8 minus 6 divided by 2. So -8 plus 6 is -2 divided by 2. That's how we get the -1. And -8 minus 6 is -14 divided by 2. That's how we get the -7. But you can see that when the discriminant is positive, your graph is going to go through the x-axis twice. So the second case is the discriminant is positive. The third case is when the discriminant is negative, and you're going to get two complex, that should be complex, two complex solutions. And the case that we're going to use here is x squared plus 6x plus 10. As you can see, this graph does not cross or touch the x-axis, which is why you get two complex solutions. So if you substitute these values, A, B, and C into the discriminant, you're going to get 6 minus 4 times 1 times 10, which is negative 4. So what we have here is the square root of negative 4. Actually, we don't need the I yet. So the square root of negative 4 is going to be 2I. And we'll talk more about that when we do complex numbers. But right now, that's just going to be 2I. So what we actually have is negative 6 plus 2I divided by 2 and negative 6 minus 2I divided by 2. So our two solutions are negative 3 plus I and negative 3 minus I. Did not need the 2. My apologies. So negative 3 plus I and negative 3 minus I are your two complex solutions. We can skip that. That's a duplicate slide. My apologies. So the first example, we need to determine the number of solutions for f of x equals 3x squared minus 5x plus 1. So all we have to do is identify A as 3, B as 5, and C as 1. And then we solve our discriminant. So we're going to have b squared, which is 5, minus 4 times 3 times 1, and that's going to be 25 minus 12, which is 13. That's greater than 0. So we have two real solutions. So if we go a step farther to find those solutions, then we just need to use the quadratic formula. So we get x equals negative b, so negative 5 plus or minus the square root of b squared minus 4ac. We did that when we did the discriminant. So we know that's negative 5 plus or minus the square root of 13 divided by 2 times 3. My apologies. So our solutions are negative 5 plus the square root of 13 divided by 6 and negative 5 minus the square root of 13 divided by 6. Those are our two real solutions. Remember, the b squared minus 4ac part is the calculation that we did here for the quadratic formula. So we get two real solutions, and they are those values. For the second example, we have 4x squared minus 9x plus 8. Same thing, A is going to be 4, B is going to equal negative 9, and C equals 8. So our discriminant is going to be negative 9 squared minus 4 times 8. So that's going to be 81 minus 16 times 8, I believe is 128. Yep. So 81 minus 128 is negative 47, and that's less than 0. So our two solutions are x equals negative b, so 9 plus or minus the square root of b squared minus 4ac, which we know to be negative 47, divided by 2 times 4. So our two solutions are 9 plus or minus I square root 47 divided by 8. That's it. So we, in this case, because the discriminant was less than 0, we have two complex solutions. And for the last example, we have 4x squared minus 12x plus 9. Same thing, identify A as 4, B as negative 12, and C is going to equal 9. And so our discriminant is going to be negative 12 squared minus 4 times 9. And 12 squared is 144. And negative 16 times 9, negative 16 times 9 is 144. So we get 144 minus 144, which equals 0. So this means we have one real solution. And that's going to mean that our solution is just x equals negative b divided by 2a, which would be positive 12 divided by 2 times 4, which is 12 divided by 8. 4 divides into both of those, so we get 3 divided by 2 as our solution. All right, so that's going to conclude our video for roots and the quadratic formula. Remember, the discriminant tells us the number of solutions that we have. If b squared minus 4ac is less than 0, we have 2 complex solutions. If b squared minus 4ac is greater than 0, we have 2 real solutions. And if b squared minus 4ac equals 0, we have 1 real solution. And finally, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a.